frame or chassis? Sorry. So chassis or frame. So everything would depend upon chassis or the frame. So what component you have to place where, and like how robust you have to make your bike. It should be in a condition so that it could take the bad road conditions or the vibrations that would be caused when you run on a particular speed. The maximum speed that you can attain from the bike, everything would depend upon the chassis, because if your chassis is not robust and properly designed, it could break down at any point of time. So say if you have a very good motor, battery is large battery, you are using everything you are using, but if say on attaining a certain velocity, or when you attain a certain speed in the bike, there can be chances that any some portion of a chassis could break. So you have to make your chassis robust, and the designing starts with the chassis. So chassis introduction, requirement, layout, designing for stability. So these are the four things that we would be analyzing. So like introduction to the chassis, type of the chassis, requirement, what all is required to make a good chassis, and the layouts, we would be also analyzing some layouts in like different models in CAD and in NSS, or even in CATIA. So types of frames we would be discussing. What are the basic types of frames? Mounting position of mid-drive motor, hub motor, and battery pack. So to give you an idea, like if you are designing a bike for a normal ICE, if you're designing it for a e vehicle, so you would see that the two major differences there would be. In your electrical vehicle, you won't have an engine would be replaced by a motor and a battery. So you have to place them accordingly, like you have to make space for battery and motor, and you have to make a decision that whether it would be a hub motor driven bike or a mid-drive driven bike. So accordingly, you have to make alterations in the chassis. And most important, that every one of you know, that we have to design it in such a way that that we maintain the center of gravity we maintain. So it should be ideally it should be in between between the two wheels. The wheelbase that we call is should be right in between the two wheelbase, and the driver, it should be positioned in such a way that that battery is placed on the center of gravity, and the driver also sits on the center of gravity. That is an like ideal kind of a design. So these things we have to keep in mind when we are designing a chassis. A chassis or frame forms skeleton and is considered as the main support of the vehicle. So as we have discussed that it is the main support of the vehicle. So everything, like when we see a bike, the plastic parts and everything makes them see very beautiful. They look like very sturdy, and different kinds of look, very sporty, and we get a feeling from them. But what does how that would be all decided through a good chassis. Chassis is is robust and very well done, then you get both the look and also you get both the reliability and the performance of the bike. So here you can see, in fact, these tires are not part of the chassis. Then the suspension system that is shown, the shocker behind, that is again also not a part of the chassis. The handlebar is not a part of a chassis. The fork or the front suspension system that is shown, that is also not a part of the chassis. So minus all these items is the chassis. Normally the chassis are to be normally are seamless, like they don't have any part that that is attached to them is not a part of the chassis. Seamless in a sense that there would be either properly welded. So anything that has to be that would be attached would be will be an annexure, or would be a separate attachment that will not be forming the part of the chassis. So all the components of a motorcycle, the suspension, wheels, seats, handlebars, battery pack, etc., are attached to this base structure, which lends a motorcycle its strength and ability to handle them. So we have discussed this again, like to clarify that The chassis, everything, every item that is moving, tires, motor, or your battery, your harness system, your like SOC or the meter, the handlebar, the front suspension system, the braking system, everything would be attached to the chassis. So chassis is usually made from welded aluminum, steel, magnesium, or metal alloy. Carbon fiber is sometimes used in expensive or custom frames. So the chassis is normally made up of aluminum or steel. Generally, we use SS or the stainless steel that we call. We use the chassis made out of them, very widely used. Then magnesium or metal alloys are used to give strength to the chassis. So if you are using say a pure aluminum or a steel chassis, to make them more robust, to give them strength, we could add we could instead use an alloy which is mixed with magnesium or metal alloy. That would give again, that would give the strength to the chassis material. Carbon fiber is sometimes used in expensive or custom frames. So carbon fiber again gives a very good strength, and the advantage that we have with carbon fiber is it reduces the chassis like anything. Like you would, it could reduce like half of the weight that we have of a normal material. Then it would reduce that weight by half. You would have seen that these cycles that these racing cycles, normal bicycles I'm talking about. So no, if you talk about them, they are like super light. If we, there are some cycles which you can like lift on your like fingers, you can lift it. So they are made up of like carbon frames. They are made up of carbon fiber material are being used to make the chassis of the material, and they make them so light that you can lift with the help of your in a single palm you can lift, or even you can balance them on your finger also. So chassis requirement, a very fundamental aspect of a vehicle that does not find a mention in even the most detail of conversation, is the chassis. So like it is like most neglected part of a vehicle. As you know that people mostly, even if you talk about a movie, only the stars are like spoken about, but the people who really uh, uh, work very hard like behind the curtain to make that movie successful are normally not given that kind of attention, or they are not they are not known. Maybe mostly they are even not known, nobody knows them. So same is the case with the chassis. So most normally neglected, even if you talk about electrical vehicles, when there are description of an electrical vehicles, most of them would either speak on motor, controller, and the battery, or even the harness, but hardly there are very detailed discussion on the chassis. But we feel that it is one of the most important part and the base of the vehicle. So we have decided to take a 2 sessions on the chassis itself. But the word fundamental cannot be emphasized enough. The chassis acts as a skeleton to the structure. So first thing first, there is no structure without the chassis. So as we said that it is the skeleton of the vehicle, and you cannot imagine a vehicle, you cannot cannot mount any part if there is no chassis, or a, and if even if you are using a weaker chassis, or you are not paying that good attention. Say if you have a project in hand where you have to uh, design a bike, and say you have got a very good very sturdy motor, like high power motor and very good battery, but you have neglected on the chassis, then it won't serve your purpose. It would it won't be a successful bike. So equal attention or a better attention has to be given on the chassis, because those components definitely, yeah, we can remove, and we could, they are detachables, but chassis once designed cannot be like again remolded. So a very high attention has to be given when we are designing on chassis, when we are designing the vehicles. The benchmark we have currently reached when it comes to structuring, design, and strength has all been based on material and mechanical innovations of the chassis. So chassis, so history of a vehicle we spoke about, all those vehicles had some or the other form of chassis. They, because the vehicle is not possible without chassis. But what, how innovation has happened in the in this item, if we speak about, then they have been as with the evolution and with time, they have become lighter and lighter and have gained strength. In fact, maybe at that time, the material that they were using was different. Now we are using material, the material that we are using now are like more sturdy, light in weight, and maybe corrosion free, and that gives you a better strength to the vehicle. So the innovation in chassis has happened in mostly in that way. And uh, the vehicles that you see today, you know that they are the top speed of the vehicles is much higher than what we have seen earlier. So in that way, the strength is very important, and the chassis has also evolved with time in form of strength, and like lighter in weight, has become lighter in weight. So chassis is of course very important, but at the same time also very indicative. There is a lot you could come to know by analyzing, knowing about the chassis of the product. It shows the class and category of the vehicle and also the price range of the offering. So the chassis normally, when you are looking at a vehicle, nobody pays attention on the chassis. So you would look the aesthetics, outer looks of a vehicle, and that would only attract you. And at the most, what you would ask there is like, what is the top speed of the vehicle, what is the average of the vehicle, like how much is the charging time. Mostly these are the top most questions that any consumer asks. But nobody like pays attention on what kind of chassis is the vehicle has, or like how robust the chassis is. Hardly attention is on that part. But since now we are discussing, when next time when you are when you are visiting or want to buy an electrical vehicle, you must have you should analyze the chassis of that vehicle also. So a good chassis, if say any OEM is giving you a very good chassis, it means that he has done very internal research he has done. So he is the most neglected part he has paid attention on. So you can imagine that his every component of the vehicle has to be like super good. It has to be very super good, because this is the part which mostly neglects, and he has paid attention on that. So you can like blindly you can say yes, it is a good vehicle. So to name few, like if you talk about say Ather or Hero, if you compare, then for Ather you would be seeing that the chassis is like very well done. The material that they have used is very robust. So which shows that the kind of research and time they have put into the vehicle. So they have not come like overnight. They have not come with a vehicle. They have put research. They have analyzed data. They have worked on the design, on the structure, on the material, everything they have worked on, and then they have come on the vehicle. So it is a like very basic that if chassis is good, the vehicle has to be good. Like it's blindly you can say yes, good chassis means a good vehicle. So chassis methodology, like how do you like when you have to design a chassis. So first is title selection, scope. So say there is a project which is there, which you have to do like on the designing of the chassis. Then title selection, scope of the project, existing system identification, proposed method approach, literature survey, selection of design parameters, design and modeling of chassis frame structure, selection of good mechanical behavior material, analyzing the modeled bike frame structure, and resultant discussion. So this is the entire life cycle. Like if you are designing a chassis, so from step 1 to step 10, these are the different steps that are being mentioned, that like which gives you an idea, like when you are designing a chassis. And from designing phase, from say from first step, from designing, from first of all analyzing in the mind, then going for the putting it into a piece of a paper, or on a or on any software. Then when you come with some design, then system identification you have to do, proposed method approach, then literature survey you have to do very intense survey you have to do, like what is normally used in the market and what extra you are trying to bring into your project. The selection of design parameters, when you have done it in the software, and in software definitely it gives you an ease that what kind of parameters you want to have. So when you are designing, you can't make it like very heavy, which is again which affects the mileage of your vehicle. So you have to keep somewhere in the between, that it is very robust, and at the same time it is also not cluttered with additional items, which makes it heavy, and again affects the mileage of the vehicle. Because in electrical vehicles, every one of you know that the weight is directly proportional to the mileage of the vehicle. Dead weight, if I say, or GCV, that gross vehicle weight, GVW, that we spoke about in the very beginning, so that has to be the lowest. So saying making it lowest, so that is the issue with most of the OEMs. Just to make this gross vehicle weight lighter, what they do is they cut on the weight of the chassis or the material of the chassis. They cut on the materials, which again hampers into the low condition, low reliability of the bike, more breakdowns, and more issues with the bike. So initially, I think in very one or first or second sessions, few people asked that is like electrical vehicles, if we talk about, are they successful because they break down, very often they break down. So so to their question, uh, am I audible to everyone?
Yes, sir, you are audible.
Okay, thank you. So the question that arose in the very first, in some initial interaction that we have. So the vehicles, normally the most of the vehicles that break are because they have selected either low category material for the chassis, or to keep the weight low, because everyone is claiming that their vehicle is going at 100 kilometer per charge. So just to keep that this mileage very high, what they have done is they have cut on the weight of the chassis, or directly cut on the material on the of the chassis. So that is a big factor which makes most of the breakdowns in the vehicle. So for a good chassis, you have to have a proper material, and at the same time you have to play between keeping the weight also to an extent, so that you are not cluttering it with too many additionals. So too many annexures, you are not cluttering it. So all those factors you have to keep in mind, and then design a good chassis. So chassis designing, CAD model of the existing chassis has been prepared in CATIA V5 as shown in figure. The dimensions were measured from the existing chassis by reverse engineering. So what this is what has been done is, this is a CAD drawing of an existing vehicle. So existing vehicle, it was like it was deassembled, and then the all components were removed from the vehicle, and then the dimensions of the chassis were taken, and then they were put into a put into a put into CAD to give this 2D model that you can see in front of you. So this is one of the design of one of an existing vehicle. This is just to give you an idea, like what a chassis would look like, an electrical vehicle chassis would look like, where you have to keep what space, and these angles and everything that has been mentioned, that those are on actuals, that these are of an existing electrical bike. So this is again a 3D model of an of a chassis. So in 3D model, you can see the two views. One is the top view, and one is the side view or isometric view, you can see. So what has been done is here you would be putting your steering and your suspension system. You would be attaching over here, and you would be keeping your battery somewhere here, and then your seat would be over here. So this is an existing 3D model. It has been shown, and to give you an idea like how a normal chassis would look like of an existing vehicle, a chassis would look like in a 3D view. So structural analysis, a general purpose commercial finite element code, hypermesh and NSS are applied to conduct the static simulations. So NSS, MATLAB and hypermesh, these are like simulation software. So what they help you to do is like, if you they have some conditions which you can like put in input some conditions, and according to the conditions you can see the output how it will behave. So if you talk about any electrical part, then it is like MATLAB. Say if you want to see like battery behavior or your controller behavior, you can put in conditions, and then you will have like output in the form of the waveforms or in the form of the digital data you will get. So that way you can see the output for mechanical, like how it would be how it would affect. So in hypermesh and NSS, you can you can see the simulation, you can see of any mechanical model, like how it would be performing. Say you put on road conditions, or you put on like on which part like stress would be applied, and if it is moving at such a speed, which part would be vulnerable, where most of the forces would be acting. A full 3D solid model is constructed for the static test simulation. Mixed types of elements which contains quadrilateral as well as triangular elements have been used in the analysis. So here analysis has been done with the help of NSS software, and they have tried to do the chassis that they have designed, like how it would be performing under different conditions. So they have tried to find it out, so that these 2D elements are converted into 3D tetra elements. So 2D, if you have a 2D model, then you can in fact convert it into a 3D model also in the software. The sensitive regions have been remeshed manually. Considered the shape and size of the parts. From the analysis, the maximum principal stress and the total deformation were determined and are shown in table one. Table 1 shows the material properties of steel and other 3 materials. So what has been trying to establish that at what force or at what parameters there would be deformation in this structure, the chassis structure that we are seeing, where it would deform, like where it would lose its properties or start crumbling. So different parameters has been changed, and at the same time the same structure has been modeled into different material. Say the initial that we spoke about, it is SS, aluminum, then maybe alloys with magnesium, and even with the composite carbon also it has been seen. So it is the study has been done to see that which material provides what strength, and at what parameters the crumbling or the breakdown of the chassis would start. And stress points also has been marked, has been identified and has been marked, and so that when we are going into when we are going into a solid model, or when we are going into an actual model, when we are at least we are aware of like what would be the stress point, how much strength has to be added to what point. So say there are points which are seamless. See, these pipes that we are talking about, these pipes are seamless, but at the same time there are also welding joints also at some point. So so there has to be we have to analyze like like how much stress these welding joints can take, and at the same time what are the bending moment properties of these pipes. So both these things have to be studied properly well, and this model gives you gives us it's kind of preventive measure, that when we are going for an actual model, we are at least ready, like what should be the basic designing parameters, and also gives me an idea of what kind of material I have to use. So these are chassis material, as I spoke about. These are the 4 material that were used to study the above model that we spoke about: stainless steel chassis, then aluminum alloy, carbon steel, and titanium. These 4 materials were studied through that model to form to make a chassis, and to find out like which material stands is best suited for our chassis. So for the material and the Young's model, poison ratio and density of the material. So what's a Young's modulus, everyone knows that, or most of the like mechanical students might be knowing about it. But for electrical students, Young's modulus is ability of material to withstand changes in length when under uh, lengthwise tension. So say if there is a pipe and the Young's model or pipe or say any material or bar or anything. So if I'm pulling it, so at some tension, like what would be the change in its length? So that is predefined after testing for every material that is defined. So here you find that the Young's modulus is highest for carbon steel and for stainless steel it is highest. So say if there are like longitudinal pulls in a bike also, some there when you are accelerating, then some parts if the are tend to like are to pushed or to be pulled. So at that time we have to use some material so that the Young's modulus is the highest, so there are no much elongation happening. So this gives us uh, uh, this table gives us a glimpse that we should be going either for stainless steel or carbon steel. So like what is Poisson ratio? Poisson ratio is again change in width per unit of material per unit of material to change in length per unit of material. So Poisson ratio is like under certain conditions, like how much its width is increasing to how much its length is increasing. Okay, so either it is like width wise how much it is expanding to how much it is expanding lengthwise. So that is the ratio. So that again has been tested under certain conditions, and it has find that like stainless steel and carbon steel has very much equal Poisson ratio only, and it is much higher for aluminum alloy. So higher in a sense, what higher signifies that under certain conditions it would be like width would be increasing much than the length. So that is again that is again goes is a negative for us. So stainless steel and carbon steel would be much suited for the chassis material. And density, we know this is the material density. So density, which what density will help us to find out that like how lighter our chassis could be. So definitely, like if we see all these aluminum stands on the top, aluminum definitely contributes. But if we see that Young's modulus is low for aluminum, we would mostly go with carbon steel or the stainless steel. So chassis designing parameters. So initially when we spoke about like what are the basic some factors or the questions that we have to answer when we are going for designing of a chassis. So loading condition, the portion of the loading condition, the portion of the handle in front is fixed as shown in figure 5 by the whitish portion, and then various loads are applied and the analysis was done. So again, this is like again simulation is we are trying to establish it. We are trying to have a simulation to find out like what would be the loading condition. So the portion of the handle in front is fixed as shown in figure 5 by the whitish portion, and then various loads are applied and the analysis was done. So like stress was the loading all was done on the chassis, and it was found that the sensitive points that you could see, like A, if you see, then it is the front portion where the suspension will go on. Then C, B, C, D, E, all these are like joint parts, but different things will be like we would be would be resting. Like if B I talk about, then you would be putting your battery, most probably your battery you would be putting on B. C, D, E, these are for like rider and a pillion would be sitting on this, so there would be different kind of stress that would be coming. So these 5 points were loaded with like different factors. Maybe I would increase the weight on C and D, and I would see like at what weight it would start crumbling or it would start deforming. So accordingly, say if I am designing my chassis for say for a loading of say 150 kgs, so 150 kgs with driver, so I would be I would be stressing and putting on C, D, E, and I would be changing different loads to find out that which where I will get stress and at what level I would get stress. So that gives me an idea of like how I could like design my chassis, and how could for my requirement, say if my requirement is 150 kgs of loading on the bike, so that what kind of material, what would be the thickness of the pipe, and what could be the this joint strength would be there, so that it doesn't start getting crumbling. So this is again a simulation of loading. Design of a chassis model. The main geometric consideration are to achieve a high performance chassis that is comprised of both advantages factor of a typical trellis frame and a perimeter frame type chassis. So when we are designing a chassis, we should be like it should be done in a proper in a proper geometric way, so that we when we are mounting all items or all the components on the bike, so then we get a like a proper distribution of the weight is done, and the stress on the chassis is minimized. So trellis frame and a perimeter frame, these are two types of chassis, so trellis and perimeter form. Features such as lightweight nature and high stiffness factor of the trellis frame gives the bike more straight line speed, while the perimeter frame is more compact, making the wheelbase shorter and also as a slight flex, which helps in high speed cornering. So features such as lightweight nature and high stiffness factor. So trellis frame, if we speak about, it is lightweight, so material would be different. We would be using like the composite carbon that we spoke about, maybe we might be using that. And high stiffness factor in a sense, like even if you are putting more weight on the chassis, then it won't bend, and so the bending moment is high of the material that we are using for the chassis. So that kind of those chassis would be called as trellis frame. And that gives more straight line speed, so that gives more straight line speed to the bike. So the straight line speed, if I speak about, that would be higher in case of trellis frame. So when we talk about perimeter frame, is more compact. It is like more compact in a sense, like it's not a very long, it is more compact. That means the wheelbase, what is a wheelbase? The distance between the centers of the two wheels would be called as wheelbase. So this is the center of the rear wheel. One second, please. Sorry. So the center of the center of the rear wheel and the center of the front wheel, the distance between these two would be called as wheelbase. So if the chassis is short, the wheelbase would be short. So in case of perimeter frame, the wheelbase is shorter. So how does that help? That making the wheelbase shorter and also as a slight flex, which helps in high speed cornering. High speed cornering, if you see like normally the sports bike, when like they are racing and everything, they have to like turn it corners at high speed. So those kind of chassis help them to tilt and help them to high speed cornering, that helps them. So those chassis are the perimeter frames. By combining both the perimeter and characteristics of these chassis, both stability and agility are achieved. The center of gravity is a point in a body or system around where the system's mass or weight is acted upon by the gravitational force. So when we are designing any chassis, we could have a combination of both. The good points of both the chassis can be taken to make a good bike, because every bike can't be a racing bike, and even every bike can't be a normal basic bike. So we have to have like some combination of features of both the chassis to make a better product. At the same time, everyone know that what a center of gravity is. So center of gravity, any body, I would say any component, any body, in any body would have would have a center of mass. So the entire gravitational force would be acting on that at that point. So in bikes also, we try to make them we need to design them in such a way that it is always like the center of gravity is at such a position, after we distribute all the component, it has such a position that it brings balance in the vehicle. So we must, if say, if when we are riding a bike, it's it balances and it moves. So major important role is played by the center of gravity. So if ideally it is between the wheelbase, we call it an ideal position of the center of gravity. So center of gravity is very important. We need to have a center of gravity as low as possible so that we can maintain the balance of the bike. Okay, so it should be such that if when attained after when it attains a certain speed, and we are keeping it straight, even we incline it, the center of gravity shifts in such a position that it doesn't allow the bike to fall. Okay, say when you are taking turns, when there are other centrifugal forces also acting on the vehicle, so center of gravity should be in such a position that when you are taking turns, when you are driving straight, when you are driving at variable velocities, variable speeds, that time also it balances the vehicle. It doesn't allow the vehicle to fall down. So the lower the center of gravity, the more stability is achieved. The wheelbase is the distance between the center of the axis of rotation in front and rear wheel. So as I spoke about the wheelbase, so most of the vehicles or all vehicles are defined also by the wheelbase, which the wheelbase is the length of the chassis. If you properly look into it, the wheelbase is the length of the chassis. So what is the wheelbase? It is the center of the front tire and the center of the rear tire. The distance between the two is called the wheelbase. And as we spoke in the last slide, also the center of gravity should be such that it is at the lowest point. So as low as the center of gravity, the more balanced a bike is. So if you talk about like bikes which have tires of diameter say 18 inches, and if you talk about other scooters, say scooty, which has mostly like 10 inches, 12 inches, so you could say that the stability or the center of gravity is lower in case of scooty in comparison to the bikes, and you could say that they could be said to be more like stable because their center of gravity is much lower. The longer the wheelbase, the straight line speed increases, but the shorter wheelbase helps with cornering stability. So if the wheelbase is longer, say or in other words, if the length of the bike is longer, that helps us to attain like a straight line speed, it would increase. But if the chassis size or chassis length or the wheelbase is shorter, that it will help us in cornering speed. Like at faster speed also you can turn on the corner. So typically if you talk about the racing bikes, they have a low like the wheelbase is smaller, and whereas in case of normal bike, the wheelbase might be a longer one. You can see that now also the new bikes, that KTM and all those bikes that are coming, they are like with a lower smaller wheelbase. You hardly have either a driver will be sitting, and at the most a pillion would be sitting, and that too is inclined in such a way. The inclination is there is an inclination because the wheelbase is short. You can't keep this like seat on a straighter like on very when you can't keep the seat straight and with a lower wheelbase, so it is inclined. So the person sitting behind you would see that he is he looks a bit taller than the driver. So that is because the wheelbase is smaller in those bikes. Rack angle is the angle of the front fork with respect to the vertical axis from drawn perpendicular to the ground. The rack angle is indirectly proportional to the steering angle and the turning radius. So what is a rack angle? So if you talk about a bike, so if you talk about the front suspension, so front suspension also we call it fork. Why do we call it a fork? Because if you pull it like if you remove it, you would see that the two shockers, the front shockers are attached in such a way that there are two shockers, then you have a cone, and then you have a spindle attached to them. So if you see that you will see in this like in the shape of fork, so we call it a fork. Okay, so rack angle, what is rack angle? Rack angle, normally if you define rack angle, if not respect to the vehicle, so say if you are using a drill machine, or if you are if you are trying to create a hole in say some material, so the angle at which you are putting your drill to the perpendicular to that material, and that the angle between both of them, that would be the rack angle. So in this case, what is the rack angle? The rack angle is the inclination, the fork between the fork and the perpendicular. So what the rack angle is indirectly proportional to the steering angle and turning ratio. So the rack angle is indirectly proportional to the steering angle and turning ratio. So more the rack angle, the lower is the turning of the bike. So if the rack angle is higher, the turning is lower, and if rack angle is lower, that you could have a higher turning ratio, turning radius. So this is the, again, initially we spoke about a few materials. So now we are trying to see how on applying the stress, how what are the results, like what are the, yeah, again, the simulations that have been done on a stainless steel frame. We have done a simulation with the help of an NSS software. So first one is for maximum principal stress, and second is for total deformation. So you could see we have marked some points which starts feeling the stress. So we have started putting forces, and we have seen that at which force which point is crumbling or breaking down. So you could see that this point takes the maximum, and this point takes the maximum. The red points that you could see, they are maximum. They takes the, when you are applying stress, these are the points which stands to the stress the most. They breaks at the end. If this is for principal stress, and this is for stainless steel material. Second is at the same time deformation. If we see, so deformation also we see that so for same applied stress, we have seen two different results. One is how which material starts crumbling, and second is deformation, where the deformation starts. So you could see that as you go, as far you go from on the end point of the chassis, or where the driver and the pillion would be sitting, then this portion deforms the last. But these portions that either the dark blue or the blue that we are seeing, they start deforming the fastest. So these are the result of when we analyze on stainless steel, we have found that this is the result. Now same set of stress when was applied on aluminum alloys, we have found how it behaves, how it behaves. Maximum principal stress we have seen, and total deformation. So why we are seeing, why we are doing this for different materials, because if we want to make a combination of chassis of combination of the materials, so which points which points I can use aluminum, and at which points I can use stainless steel. So instead of using a single material, I can have a combination of material, so that it not only gives me a strength, it saves my cost also, and I can make my chassis lighter also. So these are the principle. So we are doing these simulations just to analyze and to find out all these to answer to our questions. So we saw that this portion in aluminum deformation starts the fastest, this entire portion. So I can make this of say this portion of stainless steel at and this portion which crumbles faster in case of stainless steel, that can be replaced with the aluminum. The same we have done with carbon steel also. The same stress was applied, and we have seen how the stress points we have found out, and the deformation we have found out, the different parts of the chassis. The same chassis made up of different materials, same stress is applied, same forces are being applied, and we have seen the result of for three different materials. So this also you can see. So in this case, if you see in carbon steel, this portion which like for aluminium was like most vulnerable, which was like most vulnerable, but for carbon steel it has strength. It this is like semi blue, so it is much it gives much strength than the aluminium material that we saw in the last slide. So titanium again we have seen. So titanium we are saying. So in titanium, what we could see is like there are some places like which withstands the stress and which gives you more robustness. So after comparing all the results of all these four materials, we can take a decision like which material we will be going, whether we will be going for a single material or we could have a combination of different materials to make a robust chassis. So this is, we are trying to give you an idea like how would you analyze before going into a normal production, or you could say on a physical model. What you can do is like with the help of the software you can analyze everything, not only the material, the stress points you can analyze, the strength of your chassis you can analyze. So if you have set of data that what kind of chassis you are trying to design, like how much kg loading would be there, then like what would be the, as you spoke about, like what would be the different type of resistance that would be coming on the chassis. And if you have all those set of parameters, you can put it in the software, you can find it out how that would be behaving for different materials. That would be that would be like very helpful for you to taking decisions. So types of frames. So these are like basic. So mostly like we are studying here are two-wheeler frames, and we are trying to have a idea because with two-wheeler frames. So these are two-wheeler frames. If you talk about the categories, then we have single cradle frame, double cradle frame, backbone frame, and perimeter frame. So these are the four types of the basic frames that are available. Single cradle frame. Single cradle frame is a single down tube frame, resembles the framework of a bicycle. Okay. So single cradle frame or single down tube frame resembles the frame of a bicycle. And it is a unique steel tube that goes down to support the engine for a single cradle chassis. So in case of IC, it would be engine, and in case of like electrical vehicles, if I talk about, it would be a battery. So it also has a simple and cost-effective structure. It comprises steel tubes welded together to form a structure. It comprises steel tubes welded together to form a structure that holds the various components of the motorcycle. So it's a normally you could say that it is for lighter bikes, not very heavier bike, and it resembles with the chassis of a cycle. In some cases, the battery pack is attached to the chassis and works with it, bearing some stress. So as we said that the engine portion where you are placing an engine for a normal IC bike, you can replace it with a battery in case of electrical vehicles. This is double cradle frame. So this is most widely used if you talk about heavy bikes or normal bikes that you talk about. It is more widely used. So you could see that instead of a like a single pipe structure, it has a dual pipe structure. So these dual pipe structure give it more stability and more strength. So the double cradle or a double down tube chassis frame has two tubes going down that cradle it. So single cradle, we had a single pipe, and now in this double cradle, we have two pipes, two main pipes that we can see. A double cradle chassis is better than its single down tube counterparts in terms of strength and rigidity. So as we have discussed that the single cradle chassis is normally meant for lighter bikes. And now in mostly the bikes that we see today are double cradle chassis. That gives it, makes the chassis more rigid, and it gives the strength to the chassis. While this type of frame is the most common choice in India due to its sturdiness and cost effectiveness. So this is cost effectiveness and also at the same time sturdy. Why we need sturdy in Indian conditions? Because as we everyone knows that the road conditions are not like good everywhere. Even if the highways are good, then there would be like in the city or during the rainy season, you would have a lot of potholes on the roads, which can give you like which brings stress on the vehicle or the chassis. So if it is not robust, that could like with time being, it could help or it could result in breakdown anyway. So this double cradle is more useful for our types of condition, because it is sturdy as well as at the same time it is also cost effective. Backbone frame. So this is a backbone, this is called a backbone frame. So the backbone frame is shaped like a spine. So as the spine of the body, it is shaped something like that and holds important bike parts in place, and the engine battery pack is attached to the frame. Okay, so it holds important bike parts in place and the engine or a battery pack is attached to the frame. The amount of product used to make this is lesser than other frame types, making it very cost effective. So this, as you could yourself see the double cradle frame that we have seen, and this frame, the material that you could see that very less material has been used in this. So it is, you could say it's a kind of more cost effective than the double cradle frame that we saw in the last slide. Even though the backbone frames production is inexpensive and comfortable, it is not the first choice for many, as it lacks strength and torsion rigidity. It is the cheapest type of motorcycle chassis. So you yourself can see it, like it could give you like strength to a certain extent. Okay, so mostly it is not preferable in the modern bikes. Only very few OEMs who are manufacturing cheap bikes are using it, just to reduce the cost of the bike. So perimeter frame that we spoke about earlier, this is the perimeter frame. So normally racing bike that we saw, because perimeter frame, as we spoke about, they have shorter wheelbase. So shorter wheelbase that gives them a high speed turning advantage that it gives them. So these frames are originated on racing bikes. So they were, when they came into being, they were mostly like used for racing bikes only. The steering head and swing arm, the steering head and swing arm are joined at a short distance, reducing flexure and torsion substantially. So this what we are doing in this is like the steering head that and swing arm, they are joined a shorter distance. So they are shorter distance. So the wheelbase is shorter, and they are very close to each is very close to each other. So you would see that when racing bikes, we drive racing bike, we have to when we the steering, we have to hold the steering in such a way that we have to bend, and we have to hold the steering in such a way. So the steering in case of normal bikes that you see, they are much higher, and you don't have to bend that much. But at the same time, if you see high speed bikes, not only racing bikes but also high speed bikes that you see, they are also done in such a way that the swing arm and the steering head are joined at a very shorter distance. So you have to bend your back to hold the steering. Earlier, these frames were made from steel, but nowadays most are made up of aluminum to save weight. So they were made up of steel, but aluminum, as you know, stands in the, like when you compare weight, the weight of the aluminum is anytime like much lower than the steel. So to make those bike less heavier, we are using aluminum. So we have done, like we have spoken about about the chassis, how you could design them, what are the steps that you take before analyzing and then coming up with a chassis. And also in the middle, what we have done is we have seen some like practical, we have seen some practical simulations we have seen using different materials, and like how stress and crumbling are the output data of stress and crumbling for different materials. So, and like what kind of different chassis that are used for two-wheelers, and what are the benefits of each chassis. So now let's give you an example. Like now what we will be giving a glimpse of like how we are like working on the chassis. Initially, as we said, that it is a very neglected part, but we are giving it a very high attention, and at the same time the practical level also, if you talk about our like facility, so we have a huge setup where with the help of the advanced softwares, we are designing chassis, and with the advanced machinery we are also manufacturing the chassis. So we are not only working on manufacturing a universal chassis, but also like we have some patented designs also with us, which we are developing two-wheelers, bikes, and also the scooty types of models. So design and development of stable and sturdy chassis, we are trying to develop a stable and sturdy chassis. We have given you like analysis, and those were very much like real time, and our practical experiences that we have like last 3-4 years that we are working into this field. We have analyzed the practical data. We were one of the company who were into the on-site servicing of electrical two-wheelers and three-wheelers. So there we have analyzed data, what are the breakdowns that are happening in different parts, and mostly like why the chassis breaks, because in two-wheelers, electrical two-wheelers and three-wheelers, you will see that there after 6 or 7 months there are problems that start occurring in the chassis. So that was something we have worked very hard. We have collected data from that, and on that basis we have designed and are also producing some sturdy chassis. Democratization process of chassis design and development and initial cost reduction to support startups. So at the same time, what we are trying to do is like we are saying that chassis design is not a normally like ironsmith's work that you can give it to anybody. You give a design to him and he will just weld it, and he will give you a chassis on which you will design. It's a scientific process, and before you go for a vehicle, you have to properly test it. It should be like robustly done with proper machinery, so that you don't find a problem when you come up with when you come with actual model when you come up with. Because what happens is, if you are not going with research into say production, say today I found that without research, I have given design to someone has manufactured 1,000 chassis for me, and I am blindly, I have put on my assembly line, and I have manufactured 1,000 vehicles. But when these 1,000 vehicles go into the market, they start having issues with the chassis, let's say 2 months, 3 months, they start breakdown. At that time I can't do anything, but I have the moral responsibility, and I might be making a huge loss of reclaiming those vehicles. I have to reclaim those vehicles. So a good it should be research on very initial levels, and with good partners, so that you don't face issues when you go further. Tools and dies production for mass scale chassis development. So at the same time, we are also manufacturing tools and dies, so that different type of chassis can be manufactured. Open source availability of chassis in market, and sample die and toolkit for chassis manufacturing. So if anyone comes with any sort of designs, we have a solution available to him. We could like manufacture dies for him, and also we have ready dies for some like basic vehicle models that are supplying in the market. Here you can see like some of the photographs, like where we are doing at our facility, like the chassis after it has been designed and tested on the software, the material has been fixed. Then we start like with the help of the machinery, we have started giving it as a shape. So it's kind of a double cradle chassis. You could see it is in the making. So this is for a two-wheeler bike. We have manufactured a chassis, and also like the different steps that has been involved in manufacturing the chassis. At the same time, this cone or the steering system of a bike is also shown in the last photograph. So mounting position of motor, so it is very important. So say for a normal bike, you are keeping your you have an engine. If you talk about bikes, then it is the rear wheel is run with a transmission system in form of either chain or a belt. Or if you talk about the scooters or the scooty that we normally see, they then in those cases the rear tire is directly mounted on the engine shaft. So as the engine rotates, your tire rotates. That is kind of a direct transmission. But if you talk about like electrical vehicles, if you talk about, you have two options: either you keep it as a mid drive or you put a hub motor. So on that requirement, your chassis should be designed in such a way. So mid-drive motor is located in the middle of the bike, in between the pedals at the bike's bottom bracket, and is designed to drive the cranks or pedals and transfer the motor's power to the rear wheel via the chain drive. We spoke about that there is the transmission is to the rear wheel is with the help of the chain or the belt. Advancements in mid-drive motor technology results in smaller, lighter, and quieter e-bikes. So if you are using a mid-drive, the chances could be there that the motor could be a smaller, and mid-drive motors are a bit cheaper than your hub motor, and they are much lighter than them, and uh, are also quieter since they are not mounted directly on the wheel. So hub motor, if you talk about it, forms the rim of the rear wheel. So it has to be of that size only. Say if you are using a the tire is of a 10-inch or 12-inch dia, then your motor has to be 10-inch or 12-inch. And if you are using it for a bike, then it has to be accordingly, it has to be there. It has to be either 18-inch or mostly 18-inch. So that makes it the hub motor, it makes it bigger and also at the same time costlier. So if you are using a mid drive, that could be smaller, a bit cheaper, lighter, and also quieter. So mounting position of hub motors. So you can see here, hub motor which places the electrical motor in the center of a front or rear wheel are certainly the most common form of electric bicycle motor. So hub motor is is placed on the normally on the rear wheel only. That driving wheel is the normally the rear wheel. There are like some few people, but not very authentic designs. They have done that. They have put the hub motor in the front wheel. So they have designed them as like you could say hybrid two-wheelers. So they have petrol engine and everything, and motor is mounted in the front tire. So but that is not like very commonly used design. So hub motor normally acts as the rim of your rear wheel. You could see in this scooter that the rear wheel, if you see, the rim is the motor, okay, directly mounted onto it. So they are entirely independent drive system that retains all component inside the motor casing. So the transmission system, that is direct, no belt or no chain is involved into this. So your chassis has to be accordingly, your chassis should be there. Normally what you would see, if you are using a hub motor, you have to have a provision of double shocker. Like in the rear side, you need to have a provision of double shocker. And if say if you are having a mid-drive motor, then you can have a provision of a single or like a mono suspension system, gear mono suspension system you could have. Like you see in the scooties, normally in the scooties and the scooters that you see, they have a mono suspension system, rear mono suspension system. So mounting position of a battery. Now typical example we have given of a hub motor. Then again, like if you talk about cycles, like where you place your battery pack, you place your battery pack somewhere over here. So it is detachable, you can lock it. So we are trying to show you like in different frames on different either bike or scooty or cycles, how you have to make provisions in your chassis so that you know where you are placing, because you so that initially you know that where you are placing your battery, where your motor, what kind of motor it would be. Either it would be a hub motor or it would be a mid-drive motor. So after you have taken those decisions, your chassis should be designed accordingly. It should be designed so that it could be it could be assembled, or it could be put into the bike. So as I told you that if you're using a hub motor, normally you will have to use this double shocker suspension system. So this here it is a 48 volt battery pack for e-cycle, and here you see 72 volt battery pack on Honda Shine. So this is a on Honda Shine has been like re-engineered into an electrical vehicle. So that was all for on the first version of that we discussed today. So I hope that we have learned something on the chassis, the most important part of the vehicle. Now we will take the questions, the query session, and every one of you. In fact, I think that in last two sessions, what we have seen, only very few set of students are mostly asking questions. So I would encourage and I would want that everyone ask questions, so that at least we know that yes, you all are listening and you all are interested in the topics. Rohit, can we have the Q&A session? Hello.
Is there some issues?
No, there are no issues. I said, can we have the Q&A session?
Yeah. Rohit, are you there? Rohit, are you available?
Renuka, can we start with the Q&A session?
Friends, you can drop your queries on the chat box of what has been taught today, especially on the chases.
So, sir, last time, we discussed this format. What we have decided that anyone who want to ask a query, he can raise his hand, and at the same time, either they could be given the access, like they could unmute and they could ask question.
No issues. You can still drop your queries. Or
yeah, definitely.
I mean, we will wait for 2 minutes. Yes, Lakan has raised his hand, so Lakan can be unmuted, and Lakan, you can either drop your query onto the chat box or.
Sir, it's audible.
Yeah, Arvind, we will take your query. Lakan, your question, please.
Okay. Please unmute your mic, Lakan.
So good evening, sir. Hello.
Yeah, Lakan.
Sir, any international standards are there, sir, to make these chases?
Sorry,
Lakan, you have to speak
louder.
Sir, hello.
Yeah, Lakan.
Sir, any international standards are there, sir, to make these chases in making these chases?
Yeah, definitely there are international standards, like automobile themselves have their own standard, IS standards you must have spoken about. So whatever material you are using, what kind of bike you are manufacturing, there are standards and you have to go by those standards. So there are set standards, like what material, what grade of material you should be using, and when you are getting your chassis, the welding joints should have a proper standard, and everything. Those are according to the standards only.
I would like to add to what Govind sir has stated. Initially, the standards were fixed on physical torture of the chases. I mean, they used to be subjected to various kind of weights, overloads, and crash tests. Now, this has been simulated on a software which is done on ANSYS. It's a software package where a chassis is subjected to various kind of shear and stressful situations. That is, either weight is loaded onto it, or it is compressed from the sides, or it is compressed from front and back. And then deformity is seen on that particular chassis. So these are called as ANSYS standards, and they are specific to European and American norms. Within India, we only have what is called as a crash test, where there is a set pattern at which a vehicle is crashed onto a wall at a specified speed and weight and a load factor. And then the deformity is seen along with the possibility of harms to the driver of the vehicle. So there are set standards, but within India, as on date, there are only crash tests. Internationally, the norms are there.
Thank you, sir.
Yeah. Next question, please.
Hello, sir. Good evening. This is Uday Rajesh. Am I audible,
Can you
sir?
speak a little bit louder?
Sir, am I audible?
Yeah.
Sir, can you explain about Young's modulus and Poisson ratio?
So Young's modulus and Poisson's ratio, they are like material specific. Okay. So Young's modulus, as I said, that it is the ability of the material to withstand change in length when lengthwise tension. Say if there is a material, say iron bar is there. Okay. So if we know the material, the Young's modulus also fits because that is specific. So if say there is an iron bar and if I am pulling it, say if I am applying forces like longitudinal forces I am applying, say if I give a certain amount of force on that material, so how much there would be change in its length when I am applying a set of force, that would be defined as its Young's modulus. So material, it is material specific. Say if it is iron into iron, it would have particular Young's modulus. Then if you talk about say aluminum, it would be having its own Young's modulus. So that is like material specific. And that how is the testing done? Testing is done, say if I have to apply say x Newton force, if I have to apply on a material like lengthwise, and I see this much change in length happens, so I would define the Young's modulus is this like ABC or something, whatever. So I will define the Young's modulus in that way. And Poisson's ratio, if I talk about, say if I am applying forces on a material, so how much would be the change in its width to the change in its length? So that will be defined as a Poisson's ratio, and that will again be material specific. So if it is iron, you is a certain grade of iron, say XYZ grade of iron. So anywhere the Young's modulus would be the same, the Poisson's ratio would be the same. Okay.
So can I say that like applying the force from top side? So Young's modulus will be like increasing the length, like it will be stretching the length.
Not from the top. If we pull any material so longitudinally, okay,
Like from both sides, like
say
stretching.
from both sides, yeah, say from both sides, or say if it is fixed at one end and you are applying it force at other end, so it's a kind of pull force. If you're pulling something, how much kind of an elasticity, like if you're pulling something with some x amount of force, like what would be the change in its length? So that would be defined as its Young's modulus.
In case of width, that is the Poisson's ratio.
Yeah, if like if I am applying some force, say, and like how much is the if its width is changing something, and also its length is changing, so the ratio of those would be called as Poisson's ratio.
Yeah, got it, sir. Thank you.
Okay. So there are some like queries in the set. Can we take some text queries that?
Yeah, please go ahead.
Yeah, so Mr. Reddy, Swarankar Reddy has asked that frame and chassis. If not, what is the difference between them? So like Swarankar Reddy, frame and chassis both are same. So some people called it as, like in some nomenclature, it is called as frame, and on a much technical specification, we call it chassis. So so both are same. There is no difference between them. You have again like Sai Teja has asked, I see lot of battery in rectangle shape only. Any chance to design in different shapes of battery? Definitely there is different chances of different design also, but what happens is we have a certain geometry of the cells, so we have to depend on them only. So you can't have like when you are arranging the cells in a certain format, then you would see that the best is suited when you arrange it in either a rectangular format or a like a cubical format if you are arranging them. So we have a challenge with the geometry of the cells. So we have to be dependent on them only. So you can definitely you can arrange them in different shape, but definitely it either would be a cuboid or it would be a cube. Those structure we would be getting it mostly. That is because of the cells shape of the cells. Sai Teja, have I clarified? So there is one more question from Mr. Arvind. Sir, can you explain about the analysis result slide? So Arvind, we will take few set of questions first, and then we will go into your query. We will definitely we will go back to the presentation to explain you that slide. Anyone else? Please.
Hello.
Please post your queries, or like you can.
Hello. Hello, sir.
Hi. Yes.
Sir, you shown in the analysis result chassis
Yeah.
drawing, no, sir?
Yeah,
Sir,
yeah.
which bike chassis is that, sir?
Which?
Bikes chassis is that?
This is like famous like bike chassis only. Like we have done it on like a live chassis. It was like, I won't be naming the name of the company, but it is like very famous, very widely used motorbike.
Okay. And my another question is, what is the maximum and minimum weight that only chassis should have, sir? For IC
Minimum
engines,
minimum
maximum weight.
maximum weight. So like when you are designing a bike,
Only chassis should have.
okay, only chassis should have. So like when we are designing, see, by thumb rule I'm saying, see, designing parameters will be very, very different when you are, but by thumb rule it is like 30% is the chassis, 30% is your battery if I'm talking about electrical vehicles, and rest 30% is your other ancillaries like motor and all everything, like everything all. So it is like 1/3 of the weight of the bike should be your chassis.
Okay. For IC engine, sir?
I would like to, Govind, I would like to take the answer. IC engine is purely dependent upon the size and capacity of the engine, because that is how the vibrations come out.
Okay.
So say typically if you go for the most popular bike, that is Hero Motocorp Splendor, the chassis alone without its daughter elements, when I say daughter element, that means its handles, the T, shockers, swing arm, stand, side stand, etc., is in the vicinity of 18 to 19 kgs. Now, this is an optimum that is reached after utilizing both thicker and thinner pipes. If you have a very thin pipe structure, it will not be a sturdy frame. If you have too thick a pipe utilization for development of chassis, efficiency will go down because it will become a heavy chassis. So it has been reached after optimization. As you know, that Indian bike industry has learned a lot from the Japanese industries who have this penchant for optimizing. But the moment you go to heavier bikes, say for example a Yamaha R15 or a Bullet, which have a 350cc engine onwards till 650cc, the capability of the chassis to take the beating, because these kind of ICE engines have a lot of vibration. The chassis should be sturdy enough as a caging to take care of that and ensure that vibration is not passed on to the rider. There it goes up, where as a thumb rule, what Govind sir has stated, about 30% comes true. Because apparently 100cc engine hardly weighs around between 28 to 32 kgs, whereas a 350cc engine will weigh anywhere between 55 to 65 kgs. And as you go up on the capacity of the engine weight will increase, its capability to create vibrations on the chassis itself increases. Similarly, you require a very robust chassis to take care of that. So when you are talking of ICE engine, say for example, a cradle design which encompasses a 350cc engine will be in the vicinity of around 30-31 kgs. But the same thing, if you go for say a Hero Honda Splendor or a Boxer kind of a chassis, is less than 20 kgs. So does that answer your query?
Yes, sir. Yes, sir.
And
So-
also, sir, just sorry, sir, just to add one more thing, it would definitely again depend upon the material also you are using. Say if you're using some like composite carbon material, that definitely it would be much the percentage wise might go down. But standard that sir, what sir spoke and what I told you are on the standard chassis and the thumb rule that we spoke about. That what is mostly used in the industry.
The most commonly utilized material is MS.
Mild steel.
Yes, mild steel.
Sir, one more thing. Will the speed of the vehicle will be affected if chassis weight is more?
Pardon, if chassis weight is?
More speed of the vehicle will be affected?
No, not really.
Okay.
Just
Unless and
yeah,
unless
2-3% won't be affected, but electrical vehicles, what we do is we try to keep the as low as possible so that we could have a better mileage.
Okay, sir. Okay, thank you, sir.
welcome.
So mileage might be different, but yeah, definitely the top speed and your acceleration won't be affected.
Any more queries?
There is
Yeah,
a,
Uday.
I have one doubt, sir.
Yes.
So the material we use for chassis, there will be any chance of rust?
Can you speak a bit louder, Mr. Uday?
I sir. So the material we use for chassis,
Yeah,
is there any chances of rust for that?
very low chances because they are properly like coated with material, so there are very low chances of rust. Even for 10 normally no, years up to 10 years there won't be an issue of rusting or anything.
What
I
type
would
of
also
coating we
like
use,
to
sir?
add on to this that all chassis once manufactured, they go through a treatment
Yeah,
where the pipe is treated from inside and outside, and finally it is powder coated.
yeah. There is properly sandblasting done, then it is like properly painted so that it is uniform. It is very uniform, and the chances of rust are very low.
May I know what is the type of coating we use, sir?
Coating you could have an amalgated this polymer based coating you can have so that water could not seep into the material. So and the air and the because until unless you provide it from moisture, it would be like there won't be rusting. So it's a polymer based coating.
And one more thing, sir. What is the thickness of that coating, like in microns, sir?
Microns, definitely like I won't be able to give you a like proper figure, but there are standards, like as per the standards only that coating is there, because they are normally done with the robots and like they have a full paint shop they have, okay, so that is like analyzed and properly done according to the like standards only.
Yeah, okay, sir.
I would like to answer this. What if I say 20 microns or 25 microns? How would it make a difference?
Because sir, I have seen in some instrument transformers where I before work there. So
Hmm.
they will maintain a certain coating like up to 75 microns. So more than that, it will be like a peel off.
Yeah. So why they were maintaining so high microns, because those instrument transformers, if you talk about, they develop heat itself. Okay. So when there are heats developing the body, the material of which the body is made, it would be like going for expansion and this compression. So there would be peeling off that we are talking about. That is the main reason of peeling off. So like making the coating higher, it would be heat resistant also, and this rust resistance also. That is why they were having a high coating, double coating also, I would say. But in case the like on chassis there is no like much no heat developed as such, so they could be maintaining like a very low coating only, or low micron coating only.
Yeah. Okay, sir. Thank you.
Okay, I'll read out a question which is, sir, EV battery blasting cause huge effect of flame. Why not industry use flame prevention material for battery case? It's like you are trying to provide a solution that expects that battery will burn. The first thing is battery burns because of thermal runaway conditions, where there are multiple variables why it happens. You can't control that by putting it into a fireproof, casing. It will be commercially non-viable. The ideal reason of the battery being encased is primarily two reasons: A, safeguarding it from structural deformity, as well as ensuring that moisture does not seep inside. These are the primary requirements, which can be achieved by either a plastic box or a MS box, which is seal tight. That's the core objective. It also should have adequate amount of thermal dissipation so that heat is not collected inside. That's the objective of a battery pack. The next question, I hope this answers your query as to, EV batteries blasting cause huge effect of flames. The first and foremost is that battery packs and the cells being used should be of appropriate quality. The BMS that we use should be proper, that battery burning issues do not come up in the first instance.
Can I add something here? 2 lines
Yes.
more I can add. So like when there are like when there sir said ki you have to first like temperature management has to be done properly. Say if it has gone like it has surpassed its and it has gone thermal runaway has happened. So what will happen is like some cells will start heating. So this blast you hear, what that is the removal of the capping, because cells, if you see, those are kind of like dynamite type. So when the capping is like removed, that makes the blast. And lithium is such a sensitive that when if flame has started, it has to tend to burn. Either you can like till don't extinguish the fire, you don't put extinguisher. Even if you are extinguishing the fire, then also if you throw away the battery, there are chances that the fire can reoccur again also. So before the fire happens, there would be blast, that is the capping would be like blown away, that would be blast. Then this flame, or that would be first second step would be smoke coming out, and third would when the flame would start. So these are the 3 steps in the battery, the battery would be destroyed. So these 3 steps, so blast, and you would experience smoke coming out of it, and then third step you would see the flames coming out.
Hello.
Yes, sir.
There's one more question which says, sir, as you said, IC engine batteries run for more years, and in future, can we see EV vehicle batteries also compete with them and run for more years like IC engine? The average life of a battery pack, the ones which are used in cars like Tesla or Tata, are nearly 7 to 8 years. This is primarily because of the density of the battery cells that is being utilized and the number of cells. Even your regular two-wheeler, the battery would actually survive for 5 to 6 years. Only the issue is their efficiency will come down. When I say efficiency, basically on one single charge, if at the beginning of its life it is giving 90 kilometers, by probably 4th or 5th year, it will start giving you 50 to 60 kilometers on a single charge. So first and foremost, it doesn't come down to zero. Only thing is its utility and efficiency will come down because its capability to store energy of the cell gradually reduces. So not that battery will go down immediately after 3 years. Its life is there for 4 to 5 years. Even in regular ICE vehicles, if you see, the average lifespan is 6 to 8 years. That it works without too much of maintenance. After normally 7 to 8 years, you will see the resale value of ICE vehicle goes down drastically, because on maintenance side and on fuel efficiency, it goes down drastically. So battery vehicles are already on comparison to ICE vehicles, and if you compare the cost of fuel versus electricity, you have huge savings on electricity in electric vehicles. So this query that whether it is there or not, if you look at the total cost of ownership of a petrol vehicle to a electric vehicle for similar kind of capabilities, speed and performance. In electric vehicle, you break even in 2.5 years. You recover the entire cost of the vehicle vis-a-vis a petrol vehicle. So even if you are replacing your battery at 4 or 5 years, it is worth the game because you have recovered 2 times the cost of your vehicles. So battery cost is just 50% of the cost of the vehicle. So this query that, EV vehicles are efficient or not vis-a-vis petrol vehicles itself is wrong because electric vehicle is by default, if you look at the total cost of ownership, much lower compared to ICE vehicles over a long-term period. And my understanding is petrol is not going to come down anytime in near future. It is right now between 95 to 100 and it will only go upwards. I don't see that it is going to come down in terms of the per liter costing. In fact, many of our economies in and around, you look at Sri Lanka, cost of petrol and kerosene itself has gone through the roof. It is 234 rupees a liter or 284 rupees a liter. Last question that I am seeing is from Avinash. Sir, can a running vehicle battery charged continuous while running? In momentum, yes, it is possible to do so. But that kind of charging is not efficient equivalent to your discharge. It won't charge as much as the battery is being discharged. That ratio is probably 3% or 4%. So if you are consuming, say, 10 units, you are probably recharging only say 0.5 to 0.10 units of the battery. I hope, Sai Teja, your query, I think this is your query. It is answered. That is what, there is a specific kind of braking mechanism which charges the battery back. But that is possible only when you let go of the accelerator, not otherwise.
That also brings only 1 to 2% of difference. Only it brings regenerative braking that we call. And
Correct.
as you answered that, like continuously, if it could be charged, so we must like know more basics. The conservation of energy. We should everyone we should like brush up our concept. Whatever you are giving, like you will get lesser than that only. So even in hybrid vehicles that you speak about, there in the dynamo in your engine there is an alternator which charges the battery, but the fuel that you have to spend on charging the battery is much higher than what charge is getting into the battery. Okay, so as per the like law of energy conservation of energy, whatever when you are getting something, you have to spend more of what you are getting. Sir explained. So there is a last query by Shiva Teja. Which type of maintenance we should take when we choose an EV vehicle? So like Shiva Teja, like normally like changing shoe, like brake shoe, maintaining the condition of the tires, all those normally that you do for a normal bike that you would be doing. On addition to that, two factors that you will be seeing is you are not mostly overloading your bike. If you're overloading your bike, then that is bringing down the life of the motor. So don't overload your bike. And another maintenance is like you should be keep monitoring your like battery. Like say initially if it was giving you a a mileage of say 50 kilometers and suddenly it has come down to 25 to 30 kilometers. So those are the things that should be monitored continuously. So if you are not like overloading your bike, you are running within the parameters and everything, so then won't be issues. And all external factors like tires, your brake shoe, braking, all those as you like maintain for your normal bike, you will be doing that. But there would be, since normally if you talk about an EV, there are very less moving parts and no oil is involved. Say in engine, you have to change your engine oil, like say after 1 month or 45 days first oil change you have to do. That is nothing as such in electrical vehicles. because it is oil free. Only if you are using hydraulic braking system you are using, the oil is involved there. Otherwise there is no oil, so maintenance becomes very only you have to see only few parts, only in the moving parts. So your tires, your brake shoes, that you should be monitoring as you do in a normal bike. And at the same time you should be keep a tab on the if your battery is not draining very fast, that is the issue. And don't when you are using your bike, you should not overload your bike. These are some things if you keep in your mind, then won't be any maintenance issues as such.
Yes, sir. Fine, sir.
Yes, Shiva, and anything else you want to ask?
Okay, I had a query to the entire group. Have the groups been formulated?
I think in the very first session they were informed, sir, who is in which group.
Friends, if you are aware of the group that you are in and your fellow member, just type yes on the chat box. In case you are not, then please write or raise your hands. We would like to know, because there will be a case study that is going to be shared on what we want to do, what we intend to do. There is going to be a presentation. Swarnakar, we will answer that query, but right now if you can ask, are you guys aware of the groups that have been assigned to you? Please write yes if you are aware, please write no if you are not aware. I am waiting for the query.
Sir, this is Renuka from Medical Park LMS team. Sir, actually, we already informed to the students.
Everyone should answer this.
Yeah, we will be monitoring this. In case you are missing out, then please. As I understand, some 5 or 6 colleagues of yours are not present today.
Yeah, there are 3 students missing, I guess.
Yes. Sir, 3 students.
No issues. Renuka, first thing that I see is their numbers have not been shared, which is important. This is specifically from Arvind. Yes, sir, but don't have the contact with them. So within the group, I guess the number should be exchanged, because they are to collaborate for these presentations that we will be giving. Govind, are we giving that presentation on how to go about doing the case study today or Wednesday?
Maybe, sir, Wednesday.
Fair enough. So we will share the methodology of how you go about doing your presentations and the case study on Wednesday. And this first couple of batches will be showcasing their presentations by coming Saturday. So you have good 4 days to prepare amongst yourself. In the meantime, I would request Renuka, at least the number should be shared for the people who are in a group.
Yes, sir, definitely we will do that, sir.
That we will do, and Wednesday we are going to take up this case study based approach, where we will share what exactly this case study is. It's based on Indian scenario, and details will be shared on Wednesday.
And once the numbers are shared, it's your responsibility, guys, to interact with each
Yes,
other.
sir.
Correct. We have already defined a team lead in every group, so that Renuka and Rohit sir is going to share. I think that you already have a WhatsApp group.
Yes, sir.
And Wednesday we're going to showcase about the case study, The case study requires all the groups to prepare a presentation which has to be showcased on the coming Saturday. It's part of your marking methodology. So it is very, very critical that everybody is aware of it. Yeah. Any more questions now?
I think there was some one, sir, we missed out, so we can either.
I think I have not seen adequate yeses because this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Only 16, and we've got around 20 or 21 people. So 3 yeses are missing. My dear friend, these chats are recorded. So if someone is missing out, request participation and ensure that you please give the feedback at least. Question, the last question.
So what is the reason to use different batteries for diesel and petrol engines?
As far as my understanding is concerned, I don't think so. We use different batteries for diesel and petrol engines, do we?
No, I don't think so. I think like if we can unmute
The
the
objective of having
question.
this is from Swarnakar Reddy actually. So Swarnakar, as far as my understanding goes, the battery or lead acid battery that is used in typically cars and trucks and buses, the objective is to drive the cell initially to start it off, and later on it is a secondary source of power for all the accessories like headlight, horn, internal lights, etc., etc.
Size of the battery may be different, like only the size may be different, otherwise chemistry and composition is same.
Absolutely the same.
Yeah.
And normally these are on 12 volts.
Yeah.
That is the standard. In electric vehicles, it is a DC-DC converter which converts a 48, 60 or 72 volt battery power into 12 volts. Okay, 2 more questions. Pranav Sai, sir, now present EV scooter having range of 90 to 120 kilometers. In future, can we see more range of kilometers? Technically, yes, you can see more range, but who drives more than 140, 150 kilometers on scooter daily? You will spoil your back. Your average driving, if you see the Indian average driving is actually hardly 26 to 28 kilometers on a scooter. This I'm saying is average, not regular. Maximum you do is 60 to 70 kilometers. And say if you are from some long distance, so 120 to 130 kilometers. Beyond that, I've normally not seen bikes being utilized in a day. So this is already at the optimum level.
Yeah.
Uh,
So Pranav, to add, like the mileage is directly proportional to the size of the battery. So definitely you can get more kilometers than this if you can maintain a bigger battery. But at the same time, like you have to take a decision, like you want to have a bigger battery and make initial investment which will not be of use, because as sir said that when you are average traveling to 30-40 kilometers, why to have a very large battery for which you have to give in very high initial cost. So those are the decisions that we have to take. You can enhance your range to 200 kilometers also. You have to have a bigger size battery.
Okay, the second question is by Arvind. It's an interesting one. Sir, will the topics be given by you or side, or we should choose the topic for the case study? We have a standard matrix of around 8 topics because we are linking it to the Indian EV scenario. Virtually, it covers 360 degrees of electrical vehicles ecosystem. If you have something separate, you are most welcome. Typically, we have around 7 batches or 8 batches, as my understanding goes. So every individual batch will get one presentation topic. It cannot be replicated. In case you have your own choice, it is welcome, but the batch has to come up and give their consent to it. And once we declare it on Wednesday, by Friday, you have to close which topic you would be giving your presentation on. So yes, I guess you have the allowance of selecting your topic, but this is after the Wednesday presentation. Does that answer your question, Arvind? You can
Yes,
write a
sir.
yes or a, yeah.
Yes, sir. Yes, sir. Sir, one more question, sir. As Avinash
Yeah.
asked, can batteries be charged continuously?
So batteries can batteries can be
Batteries
charged
can charge
yeah, batteries can
continuously
be
while
yeah, batteries can be charged continuously, but you need to have some like attachments through which you have to charge. Say how you are charged. You have a second. Say you have one primary battery and one secondary battery which you need to charge. So, but this charge that will be coming out, like say you attach a dynamo, okay, on your vehicle, normally bicycle or dynamo, that you are charging your secondary battery. But this charge will stress on the primary battery, which is driving the vehicle. Okay, so you need to have a source through which energy source through which you are charging your battery. So if you talk about hybrid vehicles, as we spoke about, there is a alternator in the engine itself which charges the battery. That the battery for the lighting and everything that is charged through that alternator. But that alternator uses the fuel, either the petrol or the diesel of the vehicle to run and produce electricity. So you need to have a source through which you would be generating electricity to charge the battery. So in normal sense, it's not that my vehicle is running with the rotation of the motor, I will be generating electricity and will be charging my battery. Only one case where there would be a minor charging, and that would be regenerative braking. When you will applying brakes on your vehicle, there would be a reverse EMF generated, and that would supply some electricity to the battery to charge, say, incremental by 1% or 1.5%. That's all.
can dynamos
I would like to also add to it. Technically, you can do only one thing. Either you can discharge from the battery or charge the battery. You can't do both the process simultaneously.
Yeah, one way only it is possible.
So the electronic circuitry is defined in such a manner that once you are speeding, your accelerator is on full throttle, you are actually drawing energy from the battery. At that phase, you can't charge the battery. It's technically not possible. Only once your accelerator stops, comes to a zero or a standstill or a lower position, where the draining of the battery stops, that is only when you can start charging it.
Okay, sir.
So please understand,
more
this is the
doubt,
fundamental of any battery business, that you can't charge and discharge simultaneously the same battery.
Okay, sir. One more doubt. Can we use dynamos near the wheels to charge another battery?
We can do it, but
Yeah.
that would be discharging the battery more and charging the another battery less. So at the end of the day, there would be like more energy spent, energy you gain. Okay, so that won't be any, that won't serve our purpose. Okay, there would be no like any advantage to us.
Okay,
Your
sir.
net loss is negative.
Okay.
You are not gaining. On one side, you are pumping energy out of a battery to drive your vehicle. On another side, you are trying to extract energy using a dynamo, which will actually strain the vehicle and recharging the entire battery. Your ability to charge the battery will be lesser than the amount of energy you are withdrawing from that battery. So your net loss is negative.
Sir, can we use the technology that is used in your turbines, for what do you say?
Pardon?
Like,
Only technology possible is you attach solar panels on your vehicle. So, so the source of energy is an additional source is there. Okay, or you have a source, like you have a provision of pedals in your vehicle. So for some time you pedal it, or sometimes you drive it on the battery. So that only you can gain an incremental energy. So we have to understand this, that the law of conservation of energy. Some like there has to be some source of energy. Okay, so here when we are when the dynamo that we spoke about, the source of energy is our own battery only. Okay, but we are pedaling a vehicle, the source is coming from us. We are putting stress, we are applying force, and we are pedaling it or when you're talking about solar panels, the sun is giving us an additional energy. So by an additional factor only you can have additional energy. Otherwise, it is for same battery and like same vehicle, it is not possible to get any incremental energy.
Okay,
Okay,
sir. I understood about that. but-
friends, I'm just interrupting here. Today's session has been on chases. We would love to and invite all queries related to chases. The battery session is still to be given.
Okay.
Yeah, we have separate
There's a
two
small
sessions for
doubt.
the battery.
Yeah, so
There's a
battery
small doubt,
session
sir.
whenever. Pardon?
One small doubt. Can't we
Yes.
use a technology that is used for turbines, rotation of turbines, near dams?
So turbines, turbine is a say turbine. If you talk about it, is a turbine requires an external source through which will rotate it to electricity. So turbines can be hydro turbines, water would be used. Wind turbine, wind would be used. If you talk about diesel or steam turbine, then diesel or steam would be used. So you have to have an additional sources of input you have to have. Okay. So turbines are nothing but they would be generating electricity, but you need to have some external source which would be rotating them to generate that electricity.
Okay, sir. Okay, sir.
Any more queries? Any more queries on chases, please? Let us ideally stick to the topic of the day. So we would love to have queries on the chases.
I think, sir, we already had. Maybe like I think we have like reached, sir, our 8:30 and.
Okay, so
Lakhan has asked, sir, can you show us how to design with software? So for this, Lakhan, definitely you have to have you have to
Govind, let me answer this query. Sir, definitely we can do that, but that is not part of the current curriculum that we are giving. This is more of an in-depth overall EV. This is something separately has to be attempted using software designing tools, something like a CATIA, AutoCAD, or stuff like that. So we can very well show you a couple of slides. In fact, that is what eOxygen does when we design it. But it's a very intense subject and a separate subject altogether on the process of designing of EVs. When we come in Hyderabad to showcase our vehicles, we will obviously show you the chases. We will show you a couple of videos also. But as I told you, the entire process of designing it on the software itself is not the part of the course curriculum. This is something we can showcase as a demo to you or on videos. Does it answer your query, Lakhan? Welcome.
So I think, sir, we can wind it for today. And
absolutely yes, absolutely yes. So it has been a fairly good one, but it's a small request that we need to stick to the particular content that has been given as a demonstration for that particular day.
Yeah.
I know that the batch is quite gung-ho about going to other zones and areas of technology. Coming Wednesday, apart from the topic that has been given to give you exposure, we are also going to give you a presentation on the case study. So you have time from Wednesday onwards till Saturday. Saturday, as you know, that it's a 2-session. So a long drawn session. This Saturday is on assessment as well as for demonstration of your respective presentation. So all batches will not be covered. At least 3 to 4 batches will be covered, and we will communicate that by Wednesday itself. So guys, thanks a lot for your participation. Thanks a lot for all your queries.
Yeah, sir.
Yeah, Renuka.
Thank you so much for your participation.
Thank you, guys.
Thank you, everyone. We'll look forward to the 6th session on Wednesday.
Thanks.